Start, sir. Start, sir.
Okay. Good afternoon, my dear students. Today we are going to discuss about some more problems on differentiation by using of first principle. Now, yesterday we have given some problems. Are you completed your homework? Today, the first problem is if f of x is equal to x sin x, find its derivative by first principle. First principle. If f of x is equal to sin x, x sin x, find its derivative by first principle. Now, solution. Given function f of x is equal to x sin x. Here, x is also a variable, here also a variable. F of x plus x is equal to x plus h into sin of x plus h. Now I am clear. In place of x, we can write x plus h. That's all. X plus h into sin of x plus h. By first principle, by using the first principle, f dash x is equal to limit h tends to 0, f of x plus h minus f of x by h. This is equal to limit h tends to 0, f of x plus h means x plus h into sin of x plus h. Now I am clear. Minus f of x means x sin x by h. F of x plus h means x plus h into sin of x plus h. Minus f of x means x sin x by h. Now you can multiply with x plus h. Limit h tends to 0, x into sin of x plus h plus h into sin of x plus h minus x sin x. Am I clear? X into sin of x plus h, x into sin of x plus h plus h into sin of x plus h minus x sin x by x by h. Now, f dash x is equal to limit h tends to 0, limit h tends to 0, x sin of x plus h minus x sin x plus h sin of x plus x. For our convenience. In these two terms, x is the common. Now, limit h tends to 0. If you take x is the common, sin of x plus h minus sin x plus h by h into sin of x plus h by h. In these two terms, x is the common. If you take common, the remaining function is sin of x plus h minus sin x plus h into sin of x plus h. It can be split into two terms. Limit h tends to 0, x into sin of x plus h minus sin x by h plus limit h tends to 0, h into sin of x plus h by h dependence. Now I am clear. Now this is in the form of sin c minus sin d. This is in the form of sin c minus sin d. We know the formula. 2 cos c plus d by 2 into sin C minus D by 2. This is the formula. Sin C minus sin D equal to 2 cos C plus D by 2 into sin C minus D by 2. Now you can write limit x tends to 0, x into 2 cos, here C means x plus h, D means x, C plus D by 2, x plus h plus x by 2 into sin x plus h minus x by 2 by h plus limit x tends to 0 sin of x plus h, sin of x plus h. Now this is equal limit x tends to 0 limit x tends to 0 x into 2x into cos of x plus h by 2, x plus x 2x by 2 means x plus h by 2 into sin of minus x plus x get cancelled, remaining h by 2 by h plus limit x tends to 0 sin of x plus h. Am I clear? Cos of x plus x means 2x by 2 means x plus h by 2 plus x minus x get cancelled, the remaining function is h by h. Now this is equal limit h tends to 0, 2x is 0. Now you can limit x tends to 0 cos of x plus h by 2 into limit x tends to 0 1 by sin of 1 by 2 h by h, this one plus limit x tends to 0 sin of x plus h. Now I am clear. We know the formula. Limit theta tends to 0 sin a theta by theta is equal to a. Now 2x into cos of x plus 0 by 2. In place of x we can substitute h. In place of h we can substitute 0 into this is equal to limit theta tends to 0 sin a theta by theta. Theta tends to 0 sin a theta by theta, that is equal to a. A means here 1 by 2 plus sin of x plus 0. Put h is equal to 0 sin of x plus 0. This two get cancelled. X into cos x. Am I clear? 0 by anything equal to 0. X plus 0 means x plus sin x. This is the derivative of given function. d by dx of x sin x is equal to x cos x plus sin x. That's all. This is the derivative of x sin x. It means the derivative of x sin x is x cos x plus sin x with respect to x. That is the solution of that. Next problem. Before going to that problem, we know in trigonometry, sin of note a plus b into sin of a minus b. We know the formula. Sin of a plus b into sin of a minus b equal to sin square a minus sin square b. This is the formula. Sin square a minus sin square b. It can be written as sin square a equal to 1 minus cos square a minus sin square b means 1 minus cos square b. 1 minus cos square a minus into 1 minus 1 plus cos square. Minus 1 plus 1 get cancel. Minus cos square a plus cos square. Cos square b minus cos square. Here, sin of a plus b into sin of a minus b equal to two formulas are there. One, sin square a minus sin square b, or cos square b minus cos square. Am I clear? It is useful to our next problem. Sin of a plus b into sin of a minus b equal to sin square a minus sin square b, or cos square b minus cos square. Cos square b minus cos square a. Cos square b minus cos square. Right. Now, next problem is, it is very, very important. It is very, very important. Now, second, if f of x is equal to cos square x, find its derivative by first principle. The given function is cos square x. Find its derivative by first principle. Solution. Given function f of x is equal to cos square x. F of x plus x is equal to cos square x plus x. F of x is equal to cos square x. F of x plus x is equal to cos square x plus x. By using the first principle, f dash x is equal to limit x tends to 0, f of x plus x minus f of x by x. Limit x tends to 0, f of x plus x minus f of x by x. Here, the value f of x plus x value is, you see, limit x tends to 0, cos square x plus x minus cos square x by x. Cos square x plus x minus cos square x. We know the formula. Just now we have cos square b minus cos square a is equal to sin of a plus b into sin of a minus b. Just now we have proved. Cos square b minus cos square a is equal to sin of a plus b into sin of a minus b. One, cos square b minus cos square a is equal to sin of a plus b into sin of a minus b. Am I clear? Now, here a equal to x plus x, b equal to x, a equal to x plus x, b equal to x. This is the formula. Now, f dash x is equal to limit x tends to 0, sin of a plus b. x plus h plus x. A plus b x plus h plus x into sine of a minus b. Sorry, here b equal to, sorry, here cos square b. B means x plus h. A means x. Cos square b minus cos square a. B equal to x plus h. A equal to x. Now, sine of x plus h. A plus b into a minus b. A minus b means minus of x plus h by h. Cos square b minus cos square b. Here b means x plus h. A means x. Sine of a plus b. This is a, this is b. Here a minus b. A minus b. Now, you can simplify it. Limit x tends to 0. Sine of 2x plus h. 2x plus h into sine of x minus h by h. You can multiply with minus. Minus into x minus x. Minus into x minus h by h. Now, limit x tends to 0. Sine of 2x plus h into plus x minus x get cancelled into sine of minus h by h. Now you can apply limit. Limit x tends to 0. Sine of minus theta equal to minus sine theta. We know the value. Sine of minus theta equal to minus sine theta. Minus sine theta. Therefore, sine of 2x plus h into minus sine h by h. Take minus from outside. Limit h tends to 0. Sine of 2x plus h into limit h tends to 0. Sine h by h. This is sine of 2x plus h into this minus comes to outside. Minus of minus limit h tends to 0. Sine h by h. Now you can have minus. In place of x, we can substitute 0. Sine of 2x plus 0. 2x plus 0 into limit theta tends to 0. Sine theta by theta. We know the value. Limit theta tends to 0. Sine theta by theta. That is equal to 1. Therefore, this is equal to minus 1 into sine 2x. Sine 2x. That is the derivative of cos square x. Derivative of cos square x. Cos square x derivative minus sine x. Here only this formula is very, very important. Cos square b minus cos square a is equal to sine of a plus b into sine of a minus b. This is very, very important formula. Here b means x plus h. Sorry. B means x plus h. A means x. This is the a, this is the b. This is the a, this is the b. Sine of a plus b into sine of a minus b. Minus into x minus x. Minus into h minus h. Plus minus it cancels. The remaining sine of minus h. Sine of minus theta equal to minus sine theta. Sine theta is an odd function. Cos theta is an even function. We know sine of minus theta equal to minus sine theta. Minus sine h by h. Sine theta by theta equal to 1. That is the solution. Now, it can be written as d by dx of cos square x. We know the form d by dx of x to the power of n. Yesterday we have done x to the power of n equal to n into x to the power of n minus 1. This exponent comes to coefficient, becoming a coefficient. X to the power of n means here n is the exponent. It becomes coefficient of x. N into x to the power of n minus. It is decreasing by 1. This is the form of x square. X square means your exponent is 2. You can write 2 into cos to the power of 2 minus 1. Am I clear? X to the power of n minus 1 means 2 minus 1. Into, in place of x, here cos x is there. That's why we can write d by dx of cos x. Now I am clear? This is in the form of x to the power of n. The derivative of x to the power of n with respect to x is n into x to the power of n minus 1. In the similar way, cos square x, here in place of n, 2 is there. N into x to the power of n minus 1. But in place of x, here cos x is there, another function. That's why we can differentiating with respect to x of cos x. We know the value 2 into cos x. 2 minus 1 means 1 cos x. Derivative of cos x with respect to x. We know the value minus sin x. This is equal to minus 2 sin x cos x. Minus 2 into minus 1 minus 2 cos x into sin x or sin x. We know the formula 2 sin x cos x is equal to sin 2x. Am I clear? D by dx of cos square x. D by dx of cos square x is equal to minus sin 2x. This is the shortcut. Okay. Now the next problem is homework. One second. This is in the form of x square, x to the power of n into x to the power of n minus 1 into d by dx of cos x. 2 into cos x, derivative of cos x is equal to minus sin x. Minus 2 sin x cos x means minus sin 2x. Now, next problem is homework. You see, this is also in a exercise 98 second bit. F of x is equal to sec 3x. Sec 3x. This is the homework problem by using the first principle. F of x is equal to find its derivative by first principle. How to solve it? F of x is equal to sec 3x. F of x plus x is equal to sec of 3 into x plus x. That equal to sec 3x plus 3x. By applying first principle, f of x plus x minus f of x, sec x can be written as the reciprocal of sec theta is reciprocal of cos theta. Sec of 3x plus h is equal to 1 by cos of 3x plus h. Sec of 3x is equal to 1 by cos 3x. Take LCM on both the sides. We can apply cos c minus cos d formula. That's it. The solution of this function is d by dx of sec 3x is equal to shortcut d by dx of sec 3x. This is in the form of sec theta. We know the formula. The derivative of sec theta equal to sec theta tan theta. Sec 3x into tan 3x. Am I clear? Derivative of sec theta with respect to x is equal to sec theta tan theta. Sec x means sec x tan x. But here in place of x, 3x is there. That's why you can write d by dx of 3x. This is equal to sec 3x tan 3x into 3 into derivative of x dx by x. Derivative of x with respect to x, we know the formula. 3 into 1, derivative of x is 1. Therefore, 3 into sec 3x tan 3x. This is the short. By using the first principle, we can solve this problem. The answer is 3 sec 3x and tan 3x. That is the solution. Now, up to this stage, we can solve by using the first principle only. Now, we can write all the principles of derivatives. Standard first principle. Number 1. D by dx of x to the power of n. We know d by all the principles. Now, first of all, we can write all the principles here only. N into x to the power of n minus 1. Now, I am clear. If you take example, if you take d by dx of x to the power of 10, this is equal to 10 into x to the power of 9. Why 9? Why it is 9? 10 minus 1. You can decrease the only 1. That's why 10 into x to the power of 9. For example, if you take 2000 x to the power of 2021, it means 2021 into x to the power of 2020. Like that. Now, second formula. D by dx of x, that is equal to 1. Derivative of x is equal to 1. D by dx of constant. Derivative of constant is always 0. Example, d by dx of k is equal to 0. D by dx of minus 5 is equal to 0. D by dx of without variable term is called constant. But here in 2x, this is not a constant, coefficient of x. Coefficient of x. But here k is a constant term. This term is belongs to without variable. Minus 1 by 3 by 4. This is also a 0. D by dx of 2021, that is also equal to 0. Like that. Fourth, d by dx of root x, that is equal to 1 by 2 root x. D by dx of root x, derivative of root x with respect to x is equal to 1 by 2 root x. It is also solved by using of this principle also. D by dx of root x means d by dx of x to the power of 1 by 2. Now this is in the form of x to the power of n. X to the power of n. X to the power of n derivative n into x to the power of n minus 1. Now here n in place of n, 1 by 2 is there. X to the power of 1 by 2 minus 1. Decreasing 1. Subtracting 1. Whatever it may be. 1 by 2 minus 1 means 1 by minus 1. A to the power of minus m equal to 1 by a to the power of m. We know this form. This is equal to 1 by 2 into 1 by x to the power of 2. Minus become plus. X to the power of 1 by 2 means root x. That's why the derivative of root x is equal to 1 by root x. Already it can be solved by using the first principle also. Now I'm clear. D by dx of root x is equal to 1 by 2 root x. d by dx of 1 by x minus 1 by x square. It is also, we can sum like this. D by dx of 1 by x means d by dx of x to the power of minus 1. The exponent is 1. 1 goes to numerator, it becomes minus 1. Now this is in the form of x to the power of n into x to the power of n into x to the power of n minus 1. That is equal to minus 1 into x to the power of minus 1 minus 1. You can subtract minus 1. This is equal to, that is the solution. We can use this formula also. If d by dx of 1 by x is equal to minus 1 by x square. Next, sixth one. D by dx of e to the power of x, that is equal to e to the power of x. D by dx of a to the power of x, this is equal to a to the power of x log a base e. D by dx of log x, that is equal to 1 by x. These all are very, very important formulas. You can take care about these formulas. D by dx of log x. Now, trigonometric functions. Derivatives of trigonometric functions. Number 1, d by dx of sin x. Number 2, d by dx of cos x. Number 3, d by dx of tan x. Number 4, d by dx of cot x. What is the derivative of sin x? Cos x. Cos x derivative minus sin x. Derivative of tan x, secant square x. Derivative of cot x minus cosecant square x. Fifth one, d by dx of sec x, that equal to sec x tan x. Sixth one, d by dx of cosecant x, that equal to minus cosecant cot x. Now I am clear. Derivative of sin x is equal to cos x derivative minus sin x, tan x derivative sec square x, cot x derivative minus cos x square x, sec x derivative of sec x is equal to sec x tan x, derivative of cosec x is equal to minus cosec x cot x, plus minus alternate plus. Now, inverse trigonometric functions. Derivatives of inverse trigonometric functions. Inverse trigonometric functions. First one, d by dx of sin inverse x. Number 2, d by dx of cos inverse x. D by dx of tan inverse x. Fourth one, d by dx of cot inverse x. Fifth one, d by dx of sec inverse x. Sixth one, d by dx of cosec inverse x. D by dx of sin inverse x. 1 by under root of 1 minus x square. 1 by under root of 1 minus x square. Cos inverse x, minus 1 by under root of 1 minus x square. Tan inverse x 1 by 1 plus x square. Cot inverse x minus 1 by 1 plus x square. Sec inverse x 1 by mod x into under root of x square minus 1. This is equal to minus 1 by mod x into under root of x square minus 1. These are the formulas for sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse. Derivatives of inverse trigonometric function. How to solve it? We can discuss later. D by dx of sin inverse trigonometry. Next, hyperbolic functions. Hyperbolic functions. Derivatives of hyperbolic functions. Derivatives of hyperbolic functions. Very, very important one. Sin x, cos x, tan x, cot x, sec x, cosec x. These are called hyperbolic functions. Here x is there. This is called hyperbolic functions. Sin x derivative cos x, cos x derivative sin x, tan x derivative sec x square x. This is minus cosec x square x minus sec x tan x minus cosec x tan cot x. These are the formulas. Sin x derivative of sin x is equal to cos x. Cos x derivative sin x. Derivative of tan x with respect to x means sec x square x. Derivative of cot x minus cosec x square x. Derivative of sec x is minus sec x tan x. Cosec x derivative of cosec x is equal to minus cosec x into cot x. The first three are positive sign, remaining three are negative signs. Now, inverse hyperbolic functions. Inverse hyperbolic functions. Hyperbolic functions. Inverse hyperbolic means trigonometric functions are sin x. Inverse trigonometric function means sin inverse x. Cos x, cos inverse x. Tan x, tan inverse x. In the similar way, sin x, derivative of sin x inverse x. This is called hyperbolic function. Cos x inverse x, tan x inverse x, cot x inverse x, sec x inverse x, cosec x inverse x. These are called inverse hyperbolic functions. Inverse hyperbolic functions. 1 by under root of 1 plus x square. Sin derivative of sin x inverse x is equal to 1 by under root of 1 plus x square. This is equal to minus 1 by under root of minus 1. Only plus positive. 1 by under root of x square minus 1. Here 1 plus x square is there. Here x square minus 1 is there. Tan x inverse x 1 by 1 minus x square. Cot x inverse x 1 by 1 minus x square. Same. Sec x inverse x minus 1 by mod x into under root of 1 minus x square. Cosec x inverse x is equal to minus 1 by mod x into under root of 1 plus x square. Sin x inverse x is equal to 1 by under root of x plus x square. Cos x inverse x is equal to 1 by under root of x square minus 1. Tan x inverse x is equal to 1 by 1 minus x square. Cot x inverse x is also same 1 by 1 minus x square. Sec x inverse x is equal to minus 1 by x into under root of 1 minus x square. Cosec x inverse x is equal to minus 1 by mod x into under root of 1 plus x square. These are the very important formulas for in derivatives. Some more formulas are there. You see, for example, d by dx of k into f of x. Now I am clear. Here k is called coefficient of fx, not a constant. Coefficient like that. 2x. Here 2 is called coefficient of x. In the similar manner, here k into fx. Here k is called coefficient of fx. The derivative of this function is, you can write separately, k into d by dx of f of x. Now I am clear. This is equal to k into f dash x. That's all. d by dx of k into f of x is equal to k into f dash x. Second one, d by dx of f of x plus g of x. Let us take any two functions, f of x plus g of x. This is equal to d by dx of f of x plus d by dx of g of x. Let us take two functions. This is equal to f dash x plus g dash x. Derivative of f of x is denoted by f dash x. Derivative of g of x is denoted by g dash x. Or also, if u and v, let us say u and v are functions of x. Now d by dx of u plus v, and u is a function of x, v is also a function of x. This is equal to f dash x means u dash x, g dash x means v dash x. It can be written as like this simply: d by dx of u plus v. U and v are functions of x only. Now u dash plus v dash. That is the formula. d by dx of u plus v, sum of two functions. Derivative of sum of two functions is equal to, we can write individually, u dash plus v dash, or f dash x plus g dash x. If you take minus, okay, d by dx of u minus v, that equal to u dash minus v dash. d by dx of product of two functions, that equal to uv dash plus vu dash. Product of two functions. Here u and v are functions of x. Now coefficient d by dx of u by v, very important, vu dash minus uv dash by v square. It is very important formulas. U plus v, u dash plus v dash, u minus v, u dash minus v dash, u into v, product of two functions, uv dash plus vu dash, u by v, vu dash minus uv dash by v square. It is very important formulas. Tomorrow we can solve some problems by using these formulas only, not by using the first principle. Okay, thank you.